This is joint work with George, who seems to be the unseen person in this session, and Andres is a former student of Georgina and myself, and who's now at UNC. And make it click. See that? Yeah, sure. The paper is about life cycle labor supply and fertility. It's definitely still work in progress. It's been work in progress for a long time now. Just because we just weren't satisfied with what we had, and we're looking at the trade-off between a mother's time raising offspring and working, recognizing that working increases your human capital through experience in the same way it does in Mike and Elena's model, and many others, I guess. And how family leave policies and their variation over time and across states might affect what's going on, combined with tax policies, state tax policies that vary over time as well. In this sense, when we're thinking about conducting counterfactuals, we're not necessarily looking at a completely different regime that we haven't experienced yet. It could be that we're looking at a regime which is already adopted in a relatively small state where there aren't very many observations, and then using the structure of the model from the other states to kind of bring some discipline to what might be going on already as a trial somewhere else. Quite a few models that have both discrete and continuous choices. We introduce another way of thinking about that, or another mechanism for dealing with that. The model's semi-parametrically identified in the sense that we have to make the standard, what is a pretty standard assumption of knowing the distribution of the things that affect the discrete choices, almost always modeled as a type 1 extreme value, but then being able to get at both the distribution of the disturbance that affects the continuous choices, along with non-parametrically estimating identifying and estimating potentially the things that affect the continuous choices. So the three-stage estimation strategy is just based on the idea of number one, getting the CCP's transition probabilities out. Number two, getting a first order condition for the continuous choices. Number three, the rest. The claim that we estimate the model is an aspiration, in the sense that what we have right now are the first stage estimates of the CCPs, and we can see how well they track what's going on. And that's the sense in which we also do not have the policy innovations yet. So there are a bunch of people that have looked at this already, including some of the work that Mike's done with his co-authors, with Ken actually. And I think I'll just move on here to start out by noticing that there are significant differences across states and over time. I think I need to step out here to be able to sort of see this better. In terms of both whether there is some kind of leave policy, also what the eligibility requirements are for that, and the type of benefit, two basic types. One is, will you get your own job, your old job when you come back? Which we're going to kind of treat as some kind of quasi-human capital that you're not going to lose even though you're not working. And also, are you going to get paid while you are taking this parental leave? And so we've divided those things here. On the horizontal axis, you can see the timeline there. And for these 4 different pieces. And then you can see north, central, northeast, south, and west, referring to different regions of the states, how those have changed in these different, over this time. And we're calling that quasi-experimental, seems to be reasonable to say that. And in doing that, we are obviously ignoring internal migration that goes on in the setup. But the main thing you can see that there is a fair bit of variation. And ultimately, when we want to use some of that variation as instruments. So to be a little bit more explicit about what those diagrams show is that state taxes are low in Florida and Texas, higher in some of the Virginia and Illinois, and very high in California and a few other states. And again, what we're doing at the same time is looking at the different types of welfare that occur in these states. So first of all, we ran what should be a diff and diff, what will become a diff and diff, but what right now is a regression showing what happens to people, to women and also males when a kid is born. So the way to think about this is what was happening before the first kid is born, what happened after the first kid is born. And here you can more or less see it. As I say, we're not controlling for quite enough here, but we'll get to there. Looking at earnings, for some reason, pink is male and blue is female. I didn't design the color scheme. And you can see that male at the top left quadrant is increasing for males, decreasing for females over the years. You can see the 0 year is more or less, it's really -1. When was the kid born? It's relative before and after. And it goes out to 10 years. So you can see there's quite a significant decline in earnings. Ours worked reflects that. And it is the obverse for males. You can see earnings and ours go up slightly. Participation, similar kind of trend. And wages, if anything, for females goes down even more steeply. So that has been called the motherhood labor supply penalty. And so those are the things that we would like to explain, and then ask what happens when you introduce different types of parental leave policies that may alleviate these kinds of issues. So let's move on and look at the effect of these job-protected parental leave policies on women's labour outcomes upon mothers in terms of the correlations that Mike was looking at with his health stuff in a very parallel way. This is not structured at all. This is just what happens. And if we look at these market outcomes, blue is there's a policy, red, there is no policy, okay? And you can see when there's a policy, earnings decline, and so do hours worked, and so does the participation rate, more if there's a policy rather than if there's now I can really make things up. I was tied to my co-authors a minute ago, but
asking to wait. When they have the lead policy,
the exact opposite effect. Exact opposite effect. Exact, right. That's why I said it's similar to your health setup. It's the same thing. No worries. Let's back online. Clock's running again. And as we can see, there are these declines regardless, but when there's a policy, it declines more. Well, there's one obvious thing that's endogenous here, fertility. And so there is going to be a response by the family to when there are when there are these different types of policies versus not, as you would expect. One more point. If we're asking, well, what about males? Well, firstly, the standard errors are much bigger. There's standard deviations, really. And the second thing is you can see the blue seeping out from under the pink. And so it's not as obvious that there are as much of an effect on males, but a little bit lower participation, I would say, at the bottom ones. And perhaps, well, even the wages, I would say probably not. So here's the model. Women choosing whether to work and also how many hours to supply and whether to have a child. There is household income is going to include her spouse's income, if there's a spouse there. And that income is going to be a hard thing to calculate and require a lot of work in this case, because it depends on the family parental leave scheme and the amount of paid leave and whatever that you get when you actually have a kid. And so that required that actually absorbed a fair amount of our time as we realized that dealing with this more cleanly was necessary to get a reasonable set of results out. So the wages are determined by human capital accumulation. I mentioned these two schemes, if you like, or two aspects to parental leave policies. One being, one more time, protected leave policies that will give them wages when they return that are similar to what they would have got because they would have accumulated human capital in the meantime if they had stayed on. And the other is that they get some wages while they actually are on leave. So these people have preferences over consumption, leisure, and births, as you would imagine. And partnership or marriage and cohabiting is going to be dealt with in the following way. It's a single person optimization problem. So we're not looking at, like Lamore and George were, with the cohabiting, with the endogenous choice of marriage. However, we are allowing their partnership to follow a lag-dependent variable type of setup. And so the distribution of whether you remain married or whether you continue to cohabit, those will be driven by the set of state variables. For example, whether you already have a kid or not. So women are going to be able to smooth their financial resources over time. Won't have anything like credit constraints in this framework. And I'll go a little bit into the notation, but not too much because it's easy to get bogged down. Got years beyond adolescence, and that's going to be important when we come to looking at how well we're able to track what's going on. The calendar years are important because that is going to reflect the regimes that these different states were in at different times. And that, of course, is going to lead to, well, what do people think about this? And just to give you a heads up on this, the women in our model believe that the current regime will continue forever until they get shocked by a new regime, okay? It's hard for us to imagine, well, it's hard to model how people would anticipate these changes in regimes, particularly as we just don't have a very good estimate of how and when the process that's driving the changes in their regimes. We're only seeing them over a few years. So that is our assumption. They get surprised. And they act as if they have perfect foresight over all their other choices that they make. So consumption is just C. Ours worked is going to be a continuous variable. And ours and births are going to be, and we'll normalize it to between just 0 and 1. That's not important. Then they'll either have, won't worry about twins, a birth or not. And it's a perfectly timed decision. So when we observe a birth, we assume it was planned for that year. So they basically have a bunch of choices to make up until they end their, what we'll call fertility phase, fecundity phase, if you like. They make essentially 4 discrete choices that come from whether or not they decide to have another child and whether or not they decide to work. And if they work, they also make a continuous choice about how many hours they will work. After the fecundity phase is over, they just continue to make choices about whether they work or not. I should say a little bit more about the timing. It's probably useful to say it at this time. When you reach a period Firstly, you make your discrete choices before you see an individual idiosyncratic shock that is going to help you make your hours. Maybe I'll mention that later, but that's a piece of how we go through the identification and estimation. So there are a bunch of individual characteristics, usual kind of suspects. We also include the partner's characteristics because that's going to affect both income and the household income, and also probability of staying together. Past hours are defined separately rather than just summing them up, because these past hours really do have they have different effects depending on how recent they are in terms of your wages. And then we'll also talk about the number of kids, or use the number of kids under age 18 as both giving benefits, and also when they're much younger, how much time they take up. Notice that once you have a kid, you've got it. You can't get rid of it. And so you cannot trade off having kids now and then getting rid of them later. So as econometricians, we will never be able to distinguish between, you know, terrible twos and wonderful fives or whatever. It's you get some amount of benefit when you have the kid, and you cannot separate those other benefits out. There's just no way. And so that's the sense in which cutting out utility that you get from kids over 18 is really just saying, well, it gets incorporated into whenever you have the kid to begin with, and it's not, and it just doesn't affect your budget constraint that much, at least for these people. We're assuming that's the case. So I think that there's some nurturing that we're fixing as a given, just estimating straight off, as opposed to a choice variable. And you can see that we're just estimating it as some kind of parameter there. And so really, the amount of leisure that you have at the end of the day is, here is the amount of time you have, here is the amount of work, and here's the amount of time that you're putting into your kids, and that gives you the amount you've got time for yourself. That's the setup at that level. And in terms of I've already mentioned this stuff briefly before, that what will happen to your partnership status, and there are a bunch of them down there. You can see at the bottom of the slide, whether you're cohabiting, married or single, and also the characteristics of the partner are determined by what went on before, along with your state variables, which would obviously include kids and stuff like that. That then determines what goes on in the next period. So we're not modeling what the that process, we're almost treating it as some kind of best reply to an unspecified game of what's going on between the partners. I've mentioned and described essentially what is the differences here in parental leave time, and as I said, protected leave, future income, guaranteeing some same job, paid leave, targets current income, provides some time off at a fraction of a wages. Okay, so it's not like you get paid the whole lot, of course, and so that is where the messy work is in terms of explaining how much you get paid for how long. And we've got a little bit of notation to deal with that, and a lot of work behind it. Essentially got a couple of measures of human capital here, because you've got the actual human capital. In other words, I see what you did before, and then the fact that you haven't worked over a period, and so your human capital has or would depreciate. And in addition to that, you've got how you will get paid, a measure of the human capital that you would have if you had continued to work at the kind of rate that you were working before. Now, that's something that obviously has to be estimated, because we don't really know. But that is that we form this H star being what we'll call the equivalent human capital, given the kind of scheme that you're actually in. And so we go through a bunch of formulas to explain how that works. And I'm not sure how much I want to explain here. Just to point out some couple of things without going into the notation, I think. Depends on how hard you worked before, in terms of how many hours you worked before, because that turns out to be a determinant of the amount of leave that you will get. And it also determines the reduction in hours of how things will be calculated. So we've got a couple of kind of equations that determine how much paid leave you get, and also how much protected wage hours you will get. Wages are modeled in a fairly standard way, usual aggregate effect that affects sort of everybody's wage, some measure of efficiency in terms of your education. You can see not actual hours there, but what counts as here are your counted hours according to your protected leave hours, okay? And then these other characteristics, those are the main kind of features, I guess. The male participation in wages worked out in a similar kind of way. Here, just a standard Mincerian type equation, along with a participation decision for the male. Then budget constraint is just calculated using non-labor income to get gross household income from what you do, what your spouse does, also what you do, and other kind of labor income. So that gives you your net household income after you take into account these different tax policies, which are going to differ state by state, and hence provide some basis for estimating how people respond to different taxation policies as they choose their hours. The lifetime utility function that we have is similar to some of the work that we've done on managerial compensation, and also some of the stuff that I've done with Natalia Corancina, looking at housing. The reason we take an exponential utility is because the elasticity itself doesn't depend on income, and so that really, or wealth, that really simplifies things. Otherwise, we'd have to get all these different types of wealth and then integrate over all those different types of wealth. So if you had data on outside wealth, it would make sense to do that. But if you don't have data on outside wealth, you're really making up a distribution of outside wealth and then doing the integration. And so it's it's not clear what you really buy out of this. Having said that, in this case, you're going to have a constant elasticity of wealth. So that is the kind of trade-off that we're making here. You can see how the utility is going to depend on the number of births you have, and costs from underage kids, stuff like that. I think that's, apart from that, I think it's quite standard. So, as I said before, we're not modeling other imperfections in the market. Really, we're just looking at the imperfections that are due to the tax policy itself and the distortions or the changes that makes. And so we can talk about, in this model, an interest rate, not just today's interest rate, but future interest rates as the household in this perfect foresight world calculates how they're going to spend their consumption and make all their other decisions throughout their life. So the law of savings is going to be given by that bottom line. And then, of course, there is something that closes it off at the end of life. In this kind of model, you can construct an index of household capital. That's the A term. It is a reflection of the continuation value that you get out of these dynamic programming models, because we're using a Carnegie utility function. The continuation value is best thought of as coming in as a factor that you multiply with current consumption rather than add. We're used to thinking about U plus beta V. But when you solve for the optimal consumption in a model with Carnegie utility, it really breaks down to something like minus exponential of current consumption times what I'll call A, which takes into account the fact that with the exponential utility, of course, everything is multiplied together. And that sort of feature you can most easily see in any textbook on dynamic programming that looks at how do you smooth consumption when you've got exponential utility. And so that's where the A comes from. Now, there's more to it than that here. Buried in that equation is the inversion theorem relating the value functions to the conditional choice probabilities. And that's why that A function is written down in terms of the probabilities of what might happen in the future. And you can see that it has a recursive form, as you'd expect of any conditional valuation function, in which you've got probabilities of making these different discrete choices in the current period multiplied by what might happen to you. And there you've got, there are aspects of this that we've got to integrate over, which makes it a little bit messy. In terms of how many hours are you going to spend this period that will then add to your human capital next period. You're going to see a disturbance in a minute. And when you see that disturbance, that's going to determine your hours. We haven't seen that disturbance yet. And so we're going to be integrating how much human capital that you will have next period. So that kind of explains that second line, which is showing what is it how will things look like next period? And you can imagine by recursively substituting stuff in, you're really getting, well, what do you get this period? What do you get next period, et cetera, et cetera. Okay. So perhaps I should also point out that when you make a discrete choice this period, you are obviously going to get an epsilon associated with it. That's a type 1 extreme value thing. And that star is just reflecting the fact that you will make an optimal choice. So it'll be truncated as some kind of threshold value to reflect the fact that it is the optimal choice. Those big BTs underneath, capital BTs, are related to just bond prices and interest rates that capture the idea that whenever you get a piece of utility, that is in some sense substitutable with some consumption, and that consumption you're going to smooth. And so there's a dynamic aspect to, I get this piece of utility that I'm going to sort of smooth over the rest of my life. And so it's that's what's capturing there. And the same thing with respect to the U bars, that utility that you will get this period, which will be adjusted so that the marginal benefit of it is equated across future periods. So that is the main features of how the dynamics enters into this kind of framework. And the other part of it is to, let's put it, the other part of it is related to the bottom part of this next slide, where you're making an optimal hours choice. And here, I won't go through this in too much detail because it looks kind of daunting. This is the disturbance that's associated with it. This is coming from a first order condition. And so this psi here in utility is multiplied by H. So when you differentiate it, you've got this piece. And then the rest of it is coming from, well, how much does it increase my wages? That is one part of it. And then the other part of it is how much does it affect my leisure? And yet this third part is how much is it going to affect my human capital next period? And so in order to be able to take this first order condition and implement it, we're going to need things like conditional choice probabilities and whatever, the stuff that makes up that A that I was taking so long to explain just a minute ago, because that'll be coming back in here in order to work out what the trade-offs are with respect to the hours choice. So we assuming that we have a long panel, and in the sense that we're assuming we're able to track each person right through their life, as opposed to have a panel in which we don't know what happens to them later on. And the the way we're rationalizing that is to say that we're just building synthetic cohorts and that we have very limited amount of unobserved heterogeneity in there that allows us to be able to do that. So whereas I was talking about with the diff and diff stuff that we haven't done yet but can do, we can deal with a reasonable amount of unobserved heterogeneity at that level. But then when we come in here, not really, unless we were going to do a whole lot of integration, which we're not planning to do, at least in this paper. So that's essentially where we are now. And how much do I want to say about this identification? Not too much. Oh yes, with respect to the, I had my own timer on, but started it earlier than we. Looking at this A thing, the issue is how do we actually estimate this, given that, or identify it, given that hours today are going to affect hours tomorrow, but we also have hours tomorrow determined by that disturbance thing, which there's a disturbance there that affects that first order equation that explains why hours fluctuate a bit. So the argument that we're using here is something that goes back to stuff that I did with Sumeralto quite a few years ago. The single action, what we call single action finite dependence, in which if you stop working tomorrow and keep on not working for enough periods, you will lose your human capital. And in the case of females, that is not a particularly bad assumption to make, because you do see enough females dropping out at any time in their life so that you have some chance of being able to estimate that conditional choice probability, which is what you need then to construct this A in that way, with the dynamic correction factors that I talked about a couple of days ago. And so these are essentially retirement or leaving work or stopping work or not working choices that go out right through to the end of your working life or cap T. So that's how that is pulled together. So moving on, you basically have this logit formulation. Is that right? Yeah. Logit formulation, then determining what's over on this other side of the equation by essentially, I'm going to put it really loosely, differencing the A's that are associated with taking one choice versus a retirement choice. Now, in order to say, well, let's look at those conditional value functions. How do they differ from each other? We have a formula. This is that formula in this particular case. So obviously the utilities are only defined up to a normalizing constant, and that just leaves the business of identifying the marginal utility. And so there we're just going through the derivative of the first order condition. This is the first order condition rewritten to include or substitute in the conditional choice probabilities put in the right way for the representation of that A function or that continuation value function. That's all it is. It looks complicated, but in fact, it's not very hard. And obviously, when you're trying to identify the supply side, well, you need some instruments on the demand side. And that is why, of course, one of the main reasons why we realized that we had to look at what we'll call exogenous variation. And so that's why we had to go to these different state levels, take it seriously, different time levels, different tax rates, and get those and get that in there, which is where we're moving. So I've briefly outlined our estimation strategy. I'm not going to do it again. I want to show you essentially what we end up with the differences with the CCPs that we're estimating as a first round strategy. So to be clear, what we do is estimate the CCPs for all the different types of people and different regimes and all the rest. And then we're averaging over the CCPs for our sample population and asking how well do we come back and get the data. Okay, so in that way, we're taking account of the observed heterogeneity, let's be clear, in a fairly detailed way, and asking what kind of aggregates do you get back when you do this? And so you could ignore the observed heterogeneity if you wanted to, and you get back the data exactly if you ignored all the observed heterogeneity. Okay, we don't. But what do you get back? And you can see straight off from these four figures that if we're not talking about the really early part of the life cycle, see that with these light gray is the confidence, 95 confidence intervals there. If we're not talking about that, not only are we pretty much hitting it, well, that's partly because the diagrams are so small, but also because for the most part, the confidence intervals are very closely related to it. Okay, and so if we move around a bit and see, not the last one was according to age. Okay, now let's just look across time, because we have this time dimension as well. Not doing as well on time, you can see that, right? Because we're not picking up the aggregate effects as well, but still pretty much tracking what's going on. The CCPs, just to here, they're different. So you can actually see the difference between the dotted line and the fixed. From the fixed line, the choice just means what we actually see in the data, and the share could be just probability or population probability. And there again, you can see that we seem to do perhaps a little bit better towards the end than at the beginning, although I think probably a better way of thinking about it is that birth and work, we're not capturing that well, but no birth, no work, no birth, and the no birth ones we're getting pretty well. The birth ones are a little bit harder to get at. Moving on just a little bit more. We've got a summary of the tax stuff, and I won't talk about that, but let me just end on a couple of the fits, a little bit more on the fit here. And this is coming from the first order conditions now. And something that I'm very reluctant to move into before was as to how well we could capture hours in these kinds of models. And what you can see here is the choice of the probabilities of what's going on in the sample versus our density of hours. And so we're not picking up the peak in terms of zero quite, because 0 hours is a big deal. Okay, that's when they're not part. But on the other hand, just a minute, this is log of actual hours, excuse me. But we're not picking up this one as well, but more or less tracking okay, I think. And then if we go to the life cycle, log of hours worked again, not so good in the 18 and 20-year-olds. And I found this in another study too, the one with Carnegie in it. Same thing, the early part of the life cycle, we're just not getting very well. But once they get over 20, we can get most of it. So again, by leave regime, similar story, can pretty much pick up what's going on. And that's why we think we're fairly confident that plugging this into the structural stuff will give us something that is worth looking at. And then I think I can stop here. You can see for the last couple of things, they're all following each other. And I won't drag it through. There we go, right on time.
So we're a little bit over, given the play stuff in the game, probably added a couple more minutes. Let's have one question, and then we'll meet again at 12:00.
So is that right up the back? Yeah, go ahead.
I was making my phone break because I had a question. I have lots, so we should talk afterwards, because I'm basically also doing all this stuff in policy evaluation. And this had like jobbed ahead recently a lot, like looking at dynamic effects and all of that. What really strikes me is you're not talking at all about early childcare availability and affordability of early childcare. And recent evidence, like from the policy literature, clearly shows that this is very closely linked. And also it's closely linked to the length. It matters whether you get 3 months or you get a year or you get 2 years or you get 4 years. And so this, I've tried throughout to talk like fit it in with the European literature, where parental leave is like far more common, bigger variation, where there are nice papers, like looking at that in the Austrian context, in the German context, etc. And so I'm like trying to see a little bit like, how does that play in that? Can you talk a little bit about that, and also the early kind of childcare? Isn't like early childcare almost more important than the leave in itself? And what about employer provided full-on parental leave? I mean, that's another thing that you have like big selection into different types of firms. They're trying to hire the best qualified women. They want to keep them in the market. They're offering these packages, even though it's not mandated. So there's a huge thing going on. So
Okay, thanks.
those are the questions.
Yeah, right.
The ones you-
And so I'm not going to repeat the question, but I am going to sort of try and summarize just so that I understand what you're saying. And I think the point that you're making is that there's a lot of differentiation between the different types of support that mothers with young children have, depending on not just the leave policies that we have and also the protected work that we have, but also the nature of the childcare that's available as well. And I think that's where you're coming from. And I think that's something that we should look at, quite frankly. And I think we can, because it really depends on we've got several regimes there. We've got 6 or 7 of them. And actually having more regimes could help us, because in fact, they are not things that the mother determines. They are things that are there from, say, the political constituency or whatever that's mandated those rules. And to at least to the extent that there are rules there within states, we could actually look at that. It would be harder to not in principle, but in practice, to think about the selection of women into different types of work, depending on what kind of care is available. And the reason it's harder is because if you want to take into account the effect on their human capital and the other plans that they make for their lives, pretty soon you've got a million regimes and you're really punting on that future because you just don't have enough observations.